bunch that we have to talk about, so you have plenty of time to get some work done. I tried to figure out a shortcut for you yesterday on the symmetry rules. However, the third one, it doesn't work out that way. So I want to re-go over it just to make sure everyone's happy. You will have a question like this on the quiz that you're going to take roughly a week from today. I think it's like next Thursday, but I don't remember what day it is. So let's go through that checklist on number 27. Where was I at? Oh, so let's do the test for symmetry about the y-axis. How do we do that?
Make y negative.
That's at the x-axis.
Make x.
So, all right, so make x. And so, like, you're really plugging it in, so just be careful, please. So really, like, maybe it's better to write it like this so that you can think about what it's going to happen. And so then, what happens when you square a negative? Yeah, so then really what we have is negative x up here, positive x squared plus 1 down there. So is that the same as the... No, so then what does that tell us?
It's not equivalent.
Yeah, so it's not equivalent, so not symmetric about the y-axis. Is that okay? So that's just the same as it was. How do we test about the x-axis? Make y negative, and so then you say, okay, negative y, and then, you know, maybe if you don't like looking at the negative y there, we could divide the negative to the other side if you want. And so now is that the same? No, so then this is not symmetric about the x-axis. All right, so that's what we did yesterday. Nothing's different. But then I tried to take a little shortcut for you guys, but it doesn't work out. I couldn't think of a situation where it would matter. But this one actually matters. So to test about the origin, you got to substitute y with negative y and x with negative x. So let me scroll down and we'll work that one through. So then we would get negative y and negative x and negative x squared plus 1. And so then it's negative y over here, and then negative x, and then x squared plus 1. So is that okay? All right, but now when we divide by a negative 1 to get y positive, it'll actually divide this negative 1 away also. And so then we would have y equals x, positive x, over x squared plus 1. Does that make sense? So now is that the same as the original? Okay, so then yes, it is symmetric about the origin. All right, so sorry if I ruined your whole life because I told you wrong yesterday. I was hoping I could find a shortcut for you, but it doesn't work that way. You're going to have a question just like that on the quiz, though. Okay? So is there any questions on that? Okay? Any questions on anything else from yesterday? All right, so okay, this is the way you guys want to look at this section. You are going to want to use the graphing calculator often from here going forward. And you don't want to not know how to use it. And so all we're doing in this section is how do you go back and forth from the window so that you can see more of the graph? How can you use the table to help you answer questions, etc. So there's only one part that's kind of weird and new today, but I'm just looking at, we're talking about 53 to 89 odd. Again, make sure you're using the graphing calculator. 53 to 60 says, use a graphing calculator to graph the equation, use a standard setting, and approximate any intercepts. So all you're doing is plugging it into your calculator, looking at it, and then listing out any x-intercepts or y-intercepts. Would you like to do one of those? Or is that okay? We're good? All right, very good. If you have a graphing calculator on you, just go straight to the window. And I would always reset these. And your window looks like, if it's been reset, you did. Yeah, if you reset it, then your x-min should be -10, your x-max should be 10. The x scale, which is like what it's counting by, is 1. -10 for y-min, 10 for y-max, and then the y scale by 1. So that's when it usually starts out. So when they say standard, that's what that is. And then, like, if you look at 61, so what they're asking you to do is graph it and look at it in standard window, and then go to the window and change it to the stuff that they're saying right there. Is that okay? Again, there is a zoom button on this thing, but the zoom is really clunky. It's really too much. And so you don't want to rely on the zoom to go in and out. You want to change the window. Especially because sometimes what we're looking for is way off in the corner somewhere, and zoom won't get it for you. So is that okay? All right. 65 to 68 says describe the viewing rectangle. Now, I'm not sure what they're going to give as their answers in the back, but you could change the scale and probably see it, or you could change the window settings and probably see it. What you want to be able to do is feel comfortable changing the window to see all the important parts of a graph. So, you want to see any of the vertexes or any of the hills and valleys and things like that. So, if you manipulate your calculator and you can see the same type of thing as they're showing you, then you're doing it correctly regardless of whether or not you're exactly what the back says. Is that okay? All right, then, the new stuff then is circles. So if you want to see the formula, I'm going to write down the formula, but it's on page 111. And this is what the formula is. That's a K. Now this is going to be kind of a big deal for you because a lot of you guys are taking the ACT for the first time or maybe again. I don't like to say that I guarantee anything is on the ACT, but they seem to like circles an awful lot in the ACT. And they're really very, very easy to look at unless you've never seen one before and then you have no idea what you're looking at. Okay, so this is the generic formula for it, and it tells you two things. It tells you the location of the center, and that's going to be at HK. Now, if you're looking closely, you notice that it's subtraction here, but positive here, right? Subtraction here, but positive here. So it always switches your value when you do the center. Is that okay? And then the other information it tells you is the radius. And the radius is simply r. But please watch out because if you're given the equation, it's as r squared. So in order to find the radius, you do have to take the square root. And so they may actually just give you this, and I'll do a couple of examples, but the numbers will be filled in and they'll say, what's the center? And so it's really easy if you know what you're looking at. Or they may say, what's the radius? And as long as you take the square root of what's over there, it's a very easy question. But you guys have already taken the ACT, right? Like it gets harder as the ACT goes on. And this is usually a problem in the 40s or 50s. So it's actually really, really easy, but they don't know that you're actually going to get to it. And so then they put it way down there. But You can get a lot more complicated with a circle, but as far as the ACT is concerned, it's going to be basically this. So let's look at a couple examples. I'm actually going to start on the section 79 to 84, just because we're already looking at this, and then I'll jump back up to the other section. So I'm going to look at 82. Okay, and so then they're saying, find the center and the radius and then sketch it. So then the center, right, you don't see a value with the x, so that means it's at 0. And then just remember it's always the opposite sign. So then the center is at 0, 1. Is that okay? And then the radius, this one's kind of weird, is the square root of 1, because whatever's over here, right, you got to take the square root of. Now this one's weird because the square root of 1 is just 1. And then you can do a quick sketch of it. So 0, 1, right, with a radius of 1, so it'd look like something like that anyway. Is that okay? All right, so then, look at that. I can do it. I can do it. Is that a rough way to go? Because you guys are all full from eating, you just want to take a nap?
Yeah, and they're all 4 classes after eating.
You want all your core classes early in the morning?
I don't know, just rather not have period 1 study hall.
Yeah, period 1. Although when I was your age, I had period 1 study hall, and it was a lot different back when I was younger. Like the teacher never showed up for period 1 study hall, and so I don't even know if it was a she or he, I can't even remember, because this person was never there. But they just assigned some girl in class that would always show up to take attendance. And so I'd always show up late, and it was always on time. It was great. It was awesome. Back in the day. Yeah, back in the day. Jump up to the section above. What?
You know what you can go after that?
I can, of course there's a... I had to walk to school. I was like, yeah, I'll leave when I want to leave. As long as I get there before second period. Or actually before she did attendance. But she knew that I'd show up, and so she always got me there, even if I wasn't there. And it worked out all right. Back in the day, Grant. Remember those days? No. Let's do 74. That was way before your time, Grant. That's when kids were kids and dogs were dogs. Now kids are like adults. Dogs are still dogs, though. Oh, wait, I don't want to do this one yet. Hold on. We have dogs at home. We got 3 female dogs and 1 male dog. And it's kind of obnoxious because
What dogs are they?
mostly pug variations. One's a pure pug. One's like this 14-year-old pug beagle. And then the other one is like a pug, who knows, it's like wiener dog or something. He's like this long.
Pugs are so ugly.
Oh, but they're like the best thing in the world. Like they just come up and they snot on you and they breathe on you and it sounds like they're about to die at all times. And all they want is love. Like they just want love. They're pretty sweet. I love pugs. I had a pug before and she got old and didn't make it. And she was old. But they think they're big dogs. My old pug, Moogly, was her name. I mean, she would like be ready to throw down. I don't care what other dog was there. She would go at it. I mean, she'd always lose. I mean, she never won. But like, she was not going to be punked down by another dog. I don't know, the size didn't matter. Although she did have this one boyfriend, a buddy of mine had a big Rottweiler. And she was about the size of this Rottweiler's head. And the Rottweiler liked Moogly, like wanted to date her, you know. And like, she was uncomfortable about that situation, which I don't blame her. But anyway, old Moogly, R.I.P. Okay. So what's the equation of this circle then? Big MA. So what's those in the first one? X minus 0, okay. Plus yeah, right, always the opposite sign, equals 1/3 squared. Okay, and you probably wouldn't leave it like that, right? You'd probably say x squared here. You'd leave this part exactly as it is. And then you might write this as 1/9. Is that okay? 2 more for me. My new dog is named after Iggy Pop. If you know who Iggy Pop is. Anybody? Any music fans in here? No one likes music in here? Iggy Pop, you know the Stooges? You guys don't know the Stooges? They're like the Iggy Pop's like kind of considered the godfather of punk rock. So her full name is Iguana Pop. And I don't know if you guys are into music and you like punk music, look up the Stooges. 1969 was their first album, and it sounds like it came out like 10 years ago or something. Iggy Pop he's still out there touring. He's like 70 years old. He's an interesting cat. Yeah, well, his song though is "I Want to Be Your Dog." You may have heard that one before. There's a couple you may have heard before. Here we go, 74. Let's do 74 now. Enough about me. Let's talk about you. No, never mind. Let's just do some math. I'm sure you're extremely interested. Was it? Yeah, we just did 72, right? Yeah, I had 74 up there, but I didn't look closely enough. I was dreaming of my pugs. Get all snuggly with my pugs. Anyway, the point of the story originally was this male dog keeps peeing on our female dogs. It's freaking annoying. I know, but I feel like his territory doesn't have anything to do with the back of the other dogs, but I guess maybe it does. I don't know. He's not the brightest dog I've ever met. All right, tell me where the center is. Yeah, x minus 3 and y plus 2. Is that okay with everyone? Now, they give you the solution. They call it a solution point, but that's just a point on the circle. So the easiest thing to do to find the radius is to just plug in our x and y's and solve for r squared. So then we're going to say -1 minus 3 squared plus 1 plus 2 squared, and that equals r squared. Does this make sense? Is this okay? All right. So then that's -4 squared. That looks like 3 squared. So we got 16 plus 9. And so then 25 is what our r squared is.
Why did you just plug in 1?
Say it again.
Why did you plug in -1 and 1?
Because they gave us this as a point on the circle. Is that okay? And so then to answer the question the problem's asking, this would be the answer to your dreams. You may be asking yourself, how does he know my dreams? Yeah, it's a trick I'll show you one day. You gotta be older though to be able to get that one taken care of. Is that okay? One more for me. Oh, then you're gonna make it to English class. Good old English. You'll totally get a circle on the quiz. All right, they got endpoints of a diameter, -4, -1, and 4, 1. So that's a diameter. We need the equation of the circle. So I'm going to say we should start with the center. So what's the relationship between the center and a diameter? Was it? Yeah. What's a diameter? That's a circumference. Yeah, this is a diameter, right? So it's a relationship between the center of the circle and the diameter? It does go through it, so then like a circle is equidistant from a certain point. So half, right. So there's a formula that you guys learned in probably geometry to find the halfway point. They call it a midpoint in geometry. You remember how to find the midpoint? Well, I never remember the formula, but I remembered it anyway. So it's like this. Remember this thing? Remember that? I just remember that's the average of the x values and the average of the y values. So then we go -4 plus 4 over 2 and -1 plus 1 over 2. And that gives us 0, 0. Does that make sense? Yeah. Ah. All right. Do you say so? Man, I like me some circles. You could actually have this on the ACT. Not this one. They probably wouldn't even ask this one. It'd take too long. They just say, what's the center, boy? Or girl, depending on who's taking it. How can we find r squared? Which one do you want to plug in? It doesn't matter. That's the correct answer. Let's do 4, 1. So then it gets 4 squared plus 1 squared equals r squared. So 16 plus 1 is 17. So then this is what you get. Is that right? Is that okay? Center at 0, 0. Yep.
What did you do after the rest of it? Why did you do that?
So the ultimate goal is to come up with the equation of the circle that had these two, these two as points on the circle. They're endpoints of the diameter. They're like here and here. And so what we did was I said, okay, we got to find the center. And so the center was when we did the midpoint of these. Does that make sense? All right, so then we said, okay, the center is 0, 0. And I kind of skipped over a little bit, but like, right, you could have said x minus 0 squared plus y minus 0 squared. But then that's really just, right, x squared plus y squared. But we don't have the equation of the circle until we have the radius also. So we used the idea we did on that last problem, and I just picked, oops, oh God, what happened? What's happening there? Oh, I gotta go back here. Why did I get it there anyway? All right, so then what we had to do is use this point here and plug it into x and y to find the radius. So then 4 squared is 16, 1 squared is 1. That gave us 17 for our radius squared. Is that okay? All right, that's a good ACT. That wouldn't be it. ACT would be easier.